Hi everyone. Today I will discuss the topic exponential uh, functions. From E3 Maths 9709. So what are exponential functions? To move towards the exponential function, we should first of all uh, reflect that what is exponential. For example, we have a positive integer, let's suppose a. If we multiply this a n times with itself, then we can write it as a raised to power n, where a is the base and n is called index or power or exponent. So actually this n is called exponent. That's why this is called exponential. So there are few properties of exponentials you already know. For example, number one, rules about exponents. If there are two exponentials with same base, if they are multiplied, their powers can add up on the same base. Number two, if two exponentials are being divided with the same base, then their powers will be subtracted on the same base. Number three, if there is double exponent or double index on the same base, then these two indices will multiply each other on the same base. That could be written as n. Or if there are different bases with same exponents, then we can write these bases as a product under the same exponent. Or if two exponents with same indices, they are divided, then we can write them as a fraction under the same exponent. Okay, this is also so. The sixth very important property, if the exponent or power is 0, then the whole term will be 1. Okay, or if the exponent is a negative number, then we can write it as 1 over reciprocal of this. Then the sign of this exponent will be changed. Or if exponent is a fraction, then we can write it as nth root of that base. So these are some properties which you already know. So now, what are exponential functions? Actually, a function in which your main variable x is at the place of exponent or power or index, then this function is called an exponential function. For example, we got a function 3 raised to power x. This is called an exponential function because your main variable is at the place of exponent. If we plot the graph of an exponential function, we'll get a curve like this. This is called graph of exponential function. It is also called exponential growth. There is a steep slope at the end of the growth. This is called exponential. This starts from very low level and then rises at a very high rate. This is called exponential growth. If you want to connect this situation, today's situation of COVID-19 spread, this is the exact example of exponential growth, because at the start the virus spread was very low, but with the passage of time it is being multiplied and spreading at a very fast rate. So this exponential growth you can see in today's example. We can also see this is also the graph of an exponential function when your base is negative. This is for a greater than 0. So this is called decay graph. The best example of this graph is the half-life of radioactive element. The physics students, they can easily understand what is the radioactive element half-life. It goes like this. At the start it is very decreasing at a very fast rate, and then at the end the decrease rate is very slow. So this is called exponential function. Okay, so there are certain properties of this exponential graph function. Number one, fx is always positive. Therefore, graph will always lie above x-axis. As you can see, the graph is not going downwards, it is lying above x-axis. Number two, when x is equal to 0, fx is equal to 1, means at origin the value will always be 1. This is the property of the exponential function, because anything power 0 is 1. So when you put x equal to 0, always the value will be 1. Either it is a decay graph or a growth graph. There will be always 1 on the y-axis. Number 3 and the last, when x decreases to negative infinity, means this x is going to negative infinity, fx approaches to 0. So this fx will like touch the x-axis. So these are some examples of the exponential graphs. Now, for example, I'll discuss an example of the exponential function. How we solve this example exponential function questions. There is an example. Let's suppose solve the following equation. Three raised to power 2x plus 1 plus 23 into 3x minus 8 is equal to 0. Let's suppose we have to solve this equation. So we can see the exponential functions in this equation. Okay, how can we solve it? For example, I can write it as 3 raised to power 2x into 3 power 1, because the very first rule of the index, when two exponentials are being multiplied, their powers can be added up, and we can go other way around. If the two powers are being added up on a same base, we can split them. Now, we can suppose let y is equal to 3 raised to power 2x, because we have to make this equation simple and solvable. So we can suppose, so actually we can suppose 3 raised to power x is y. Okay, then 3 raised to power 2x can be y square, because 3 raised to power x power to double exponent is actually 3 raised to power 2x. So the square of 3x is actually 3 raised to power 2x. So we can write it as squaring both sides. 3 raised to power 2x is y square. Put the values here. It will be 3y square 23y minus 8 is equal to 0. Okay. Now, this is a quadratic equation in the form of y, variable y. So we can solve it by midterm break method. Like 3y square plus 23y minus 24y, sorry, 24y minus y minus 8 is equal to 0. So take 3y common, y plus 8, take minus 1 common, y plus 8 is equal to 0. Now take y plus 8 common, 3y minus 1 is equal to 0. So y plus 8 is equal to 0, 3y minus 1 is equal to 0, y is equal to minus 8, y is equal to 1 over 3. Now actually our main question is in variable x, so we have to put the value back which I supposed at the start. So I'll put 3x instead of y now. This will be 3x minus 8, or I can write it as because this is not possible, I cannot write this minus 8 in the as a base of 3. So this is not possible, I cannot solve it, this is not solvable, so I'll stop here. And now this 3 raised to power x is equal to 1 over 3. Now this can be written as 3x is equal to 3 raised to power minus 1. Both bases will be cancelled, x is equal to minus 1. This is the answer. So these are called exponential functions. That's it. This is the end of the video. Thank you very much.